Hello everyone, hope you are enjoying happy life and good health. I am Muhammad Asif. Our today's topic is ionic or electrovalent bond. The definition of ionic or electrovalent bond is bond formed by complete transfer of electrons from metal atom to non-metal atoms. This is the definition of ionic or electrovalent bond. Bond formed by the complete transfer of electron from metal atom to non-metal atoms. In the previous lecture, I have explained that what is bond. Bond is a force of attraction that might be created by any process. One of the process is due to the transfer of electron. In the previous lecture we have already discussed that metal atoms lose electron and non-metal atom gain electron whenever metal atom lose electron. For example is NaCl formation. NaCl formation. How this takes place? In the formation of NaCl, sodium atom is present. Its proton number is 11. Its electronic configuration is 2, 8 and 1. As the last shell contains 1 electron, this electron will be lost easily and sodium will be converted into sodium ion. That will be called as cation. Now, the proton number of the sodium ion will remain the same, but due to the loss of 1 electron, the electronic configuration will come just like this. This is the electronic configuration of noble gas. That's why in comparison with sodium atom, sodium ion is more stable with minimum energy. On the other hand, we know that we have second atom, chlorine. Its proton number is 17. Its electronic configuration is 2, 8 and 7. Means the last shell contains 7 electrons and only 1 electron is short to complete its last shell. So it will gain 1 electron and will be converted into chloride ion, which is called as anion. The proton number will remain same, 17, and the electronic configuration will become 2, 8 and 8. And this electronic configuration is again of noble gas. It means that chloride ion is more stable as compared to chlorine atom. Now, the electrostatic force of attraction between this sodium ion, which it will be present in the gaseous state definitely, and between chloride ion, which will also be present in the gaseous state. Now, NaCl solid will form. The force of attraction between these charges, that will be called as electrostatic force of attraction. Now, the electrostatic force of attraction between positively charged cation and negatively charged anion, this is called as ionic bonding, and sodium chloride is formed as a result of ionic bond between cation and anion. Now, if we represent the electronic configuration, if we draw electronic configuration can be represented as, for example, in case of sodium, this is sodium nucleus. First shell contain 2 electrons, second shell contain 8 electrons, and third shell contains 1 electron. When this electron will be lost, then this will become just like this. First shell contain 2 electrons, and the last shell will contain 8 electrons, and this will be represented as just like this, +1. Now this +1 charge is indicating that 1 electron has been lost from this species. This is sodium ion, this is sodium atom. In the similar manner, chlorine and chloride formation can also be represented as, look at this. For example, if I represent chlorine, this is Cl, first shell contain 2 electrons, second shell contain 8 electrons, and third shell contain how much? 7 electrons. 7 electrons. Now, only 1 electron is short. If this chlorine atom gain 1 electron, then this will be represented as, Cl. First shell contain 2 electrons, second shell contain 8 electrons, and third shell also contain 8 electrons. And this is represented just like this with brackets with -1 charge. It means that 1 electron is additionally added into this species, and chlorine atom has been changed into chloride ion. Now, this is the simple representation, but if we have to show the electron dot cross model, if we have to follow the electron dot cross model, then one atom electrons can be represented by these dots, and the other atom electrons will be definitely represented by cross. For example, if we represent the electron of sodium atom and sodium ion in dot form, definitely we will represent the electrons of chlorine and chloride ion in the cross form, and that cross form can be represented as just like this. For example, I am going to representing all these electrons in cross form. Now, 1, check the representation of electrons. I am explaining now dot cross model. Dot cross model. All the electrons are represented by cross, and all the electrons of sodium are represented by dot. Now again similarly, in case of ions, all the electrons can be represented as cross. All the electrons are represented by cross. Now this is representing electron dot cross model. Electron dot cross model. Now only one electron which is shifted from sodium, because the electron of sodium were represented by dot. One electron which is additionally entered into chlorine atom, that will be represented by dot. Rest of the electrons of chlorine will be represented as cross. Now, if we have to represent this electron dot cross model for sodium chloride, then sodium ion along with this chloride ion are represented side by side. Now, in this case, we represent plus sign along with, and then represent chloride ion. This is Cl. First electron contains 2. First shell contain 2 electrons. Second shell contain 8 electrons. And third shell contain again 8 electrons. But one electron is represented by this dot for the electron which is coming from sodium atom. So now this -1 represents the gain of one additional electron, and this +1 represents the loss of one electron from the last shell of an atom. The loss of electron takes place from metal atom, gain of electron takes place in non-metal atom. Now, these charges which comes on atoms after gaining or losing electron, these are also called as valency of the atoms. For example, the valency of sodium is +1 because it has lost one electron to complete its last shell. In the similar manner, the valency of chloride ion is also 1 -1 because it has gained only one electron to complete its last shell to get the inert gas electronic configuration. Now remember, in case of ions, electronic configuration of all the ions will be definitely just like noble gas electronic configuration. When noble gas electronic configuration is attained, then the electrostatic force of attraction between cation and anion, this is called as ionic bond. This is the electrostatic force of attraction. Now this electrostatic force of attraction depends upon two factors mainly. If the charges are more, instead of +1 it comes +2 or +3, and negative charge instead of +1, if it becomes -2, -3, then the electrostatic force of attraction will be increased considerably, too much. For example, in case of magnesium oxide, we know that magnesium, it has proton number 12, electronic configuration 282. This loses 2 electron and become magnesium ion with electronic configuration 28, inert gas electronic configuration. In the similar manner, oxygen has proton number 8, electronic configuration is 26, and to complete its last shell it gains 2 electrons and becomes oxide ion with -2. Now the electronic configuration comes to 8. This electronic configuration is of noble gas. So the force of attraction between magnesium ion and oxide ion, as the charges has become doubled as compared to sodium chloride, the electrostatic force of attraction between these two cation and anion will be much more stronger as compared to sodium chloride. That's why the melting point of sodium chloride is 801, but the magnesium oxide melting point is too much. Then this is in thousands. Approximate its melting point is 2960 degrees centigrade. Too much. It means that the melting point is directly related with the electrostatic force of attraction. Stronger the electrostatic force of attraction, much higher the melting point. And if the electrostatic force of attraction is less, then the melting point will also be less. The second factor, most important, is the size of cation and anion. If the sizes are larger, then the melting point will be lesser. Electrostatic force of attraction will become very weak, but if the sizes are smaller, then the electrostatic force of attraction will be much more stronger and the melting point of the substances will be very much high. Now, this is the second example of ionic bond. So many examples of ionic bond can be explained, as I have explained in the previous lecture, that group 1, group 2, group 3 metals can formulate ionic bond with group 6 or 7. All those are the examples of ionic bond. Now, all those substances which contain ionic bond, those are called as ionic compound. Ionic compound. For example, magnesium oxide. For example, all these compounds which I have explained, NaCl, MgO, these are the ionic compound due to the presence of ionic bond in them. Similarly, potassium bromide, potassium iodide, sodium fluoride, sodium bromide, all these are also ionic compound. Calcium chloride, magnesium bromide. Similarly, strontium oxide, all these are ionic compounds because they are formed by the ionic bond, by the complete transference of electron from metal atom to non-metal atom. Now, whenever we compare the properties of these ionic compounds, what are the important properties of ionic compounds? Properties of ionic compound. Number 1, crystalline form, crystalline shape or geometry. All the cations and anions, they arrange themselves alternatively. Alternatively mean if here is cation, then the next will become how these will be arranged? These will be arranged just like this. These are anions. And These anions will also be present just like this, and then cation will be present alternatively in between them, so as electrostatic force of attraction remains all the time in between cation and anion. Now, crystalline shape. All these cation and anion arrange themselves in a definite regular pattern. That's why these are all called as crystalline solids. Crystalline solids. Now, as I have explained, these have high melting and boiling points. Melting points and boiling points. Boiling points. All the ionic solids have very high melting and boiling point than usual because the electrostatic force of attraction is present between them. That's why these ions, due to very strong force of attraction, have a definite shape and they are always present in solid state. Third is physical state. Physical state is always solid because due to the strong force of attraction, all these particles are fixed at their respective position. They cannot leave all these. Now, volatile nature. Volatile nature. Due to the strong electrostatic force of attraction, cation and anion cannot leave their respective position, so they are non-volatile. That's why they have no smell. Due to non-volatile nature, they have no smell. Next is solubility. Majority of the ionic solids are soluble in polar solvent just like water. Some of the solids are exceptions which are insoluble in water, but majority of the ionic solid are soluble. For example, NaCl, for example, CaCl2, for example, CuSO4, for example, Na2CO3, for example, MgSO4. All these are the solids which are soluble in water, but there are some ionic solids which are insoluble water. From the solubility rules, we can easily judge which type of ionic solids are insoluble in water. Insoluble in water are, for example, lead sulfate, PbSO4, calcium sulfate, for example, mercury sulfate, for example, lead sulfate, for example, carbonates, all carbonates other than sodium, potassium and ammonium, all these are insoluble, but majority of the ionic solids are soluble in polar solvents. Now, electrical conductivity. Electrical conductivity all ionic solids have fixed cation and anion at their position, so in solid state they will not conduct electric current because their cations and anion are fixed at their position. So in solid state they are non-conductor of heat and electricity. These are in solid state. In solid state, ionic solids are non-conductor. non-conductor. But in liquid state, or fused state, all these ionic solids are conductor and becomes electrolyte. These are in liquid state or in aqueous state. These become electrolyte. These can easily conduct electric current because in molten or in aqueous solution, cation and anions are easily movable. They can migrate from one point to another. This is the important property of electrical conductivity of these ionic solids. Now, next is nature of bond. Nature of bond. Nature of bond mean and nature of bond. Ionic bond is non-directional. Non-directional means in case of cation and anion, if we consider cation and anion as a sphere of charge, then it will apply force of attraction in all directions, up, down, left, right, back, front, in all directions. So from all directions, if oppositely charged ion will comes, it will attract. That's why this type of bond or electrostatic force of attraction is called as ionic bond, and this ionic bond is non-directional, means it can apply force of attraction in all the directions. That's why ionic bond is called as non-directional. Non-directional. Now, in case of ionic bond, I have already explained in previous video that group 1, group 1A, group 2A and group 3A elements are metals, and from group 5A, rather 4A, 5A, 6A, 7A and group 8. All these are non-metals. All these are non-metals. Now, group 1 metals are having maximum metallic character. Maximum metallic character. The metallic character of second A group is less, and metallic character of third A group is further less. That's why the bond formed between group 1A metal and group 7A non-metal is considered to be having maximum ionic character. The ionic bond formed between second A group and 6A group non-metals is considered to be having less ionic character, and similarly the elements of group 3A metals and all these non-metals, they will form ionic bond with the less ionic character first. Now, what is the reason of this? Normally, ionic compound has high melting and boiling point with few exceptions. For example, ammonium chloride. For example, ammonium nitrate. Both of these compounds is considered to be ionic. In ammonium ion, covalent bond is also present, and ammonium ion itself is ion. Chloride is ion. So this compound contains three types of bonding: ionic, covalent, and coordinate also. In the similar manner, ammonium nitrate also contains three types of bonds: ionic, covalent, and coordinate covalent bond. Now, as compared to the other ionic bond, the melting point of these compounds, ammonium chloride, this sublimes. It means that whenever have a heat energy will be provided to the ammonium chloride, it will change into vapors. It means that this ionic compound has some exception from these ionic compounds. These ionic compounds have very high melting and boiling point, while ammonium chloride has a little bit less melting point. Similarly, ammonium nitrate has a melting point of 170 degrees centigrade. It means that no doubt it is ionic compound, but have a little bit exception, its melting point very less. What is the reason? It means that the ionic compound which are composed of metal and non-metal categorically, they will have a very high melting and boiling point. But in this case, these are the ionic compound, but no metal atom is present in it. That's why the force of attraction between these ions is not too much, just like those ionic substances. That's why the melting point of these ionic solids are quite less. That's why these are the important properties of ionic compound. Next is the important property of ionic compound is brittleness. Brittleness. What does it mean? It means that if we have brittleness, for example, if we have ionic compound and if we apply force on it, what will happen? Because all cation and anion are arranged in layered structure, that's why on applying force the layers will slip over one another. And due to the slipping, what will happen? The first layer will become just like this. The first layer will become just like this. Now, due to slipping of this first layer, what will happen? The negative charge come in front of negative charge and positive charge come in front of positive charge. What will happen? A force of repulsion will be created. As a result, the ionic solid will be broken down, and this breaking up of ionic solid into smaller pieces on applying force, this is called as a brittleness. This is the property of the ionic solids. If the substances torn into smaller pieces on applying force, then definitely this property is called as brittleness, and this is also important of property of an ionic solids. Brittleness means break up into small pieces. Brittleness. Now, all these are the properties of the ionic solids, definitions and explanation how ionic bond is formed. I have explained all these points one by one. I hope you have understood all these well. In case of any confusion, you can contact on study of change page.